What if I told you that one of the best guides on how to explain, well, anything, is hidden inside a document that looks, frankly, about as boring as it gets? Today, we're going to deconstruct a 1999 US military standard, and trust me, we're going to uncover a total masterclass in clarity and order.
So let me just ask you a question. What could a multi-million-dollar high-tech computer system possibly have in common with that IKEA bookshelf you probably struggled with last weekend? The answer, as you're about to see, is actually pretty simple.
That's it. They both need a really good instruction manual. Whether you're firing up a critical piece of hardware or just trying to figure out which little screw is which, the quality of the instructions is what separates success from a pile of junk on your floor. And when the stakes are really high, good enough is not good enough.
So here's our game plan. First, we're going to meet the ultimate instruction manual. Then, we'll get into why manuals need such strict rules in the first place. After that, we'll dissect the anatomy of a perfect one, follow its procedures from power on to troubleshooting, and finally, we'll see what this all teaches us about what great manuals do.
All right, first up, let's meet our subject for today. It's a document with the very catchy name DIDIPS C81446A. This is the military's official guide for how to write another guide, specifically a computer operation manual, or COM for short.
Now, the whole reason this thing exists is what makes it so important. It's designed for those situations where a computer system is so new or so specialized that no commercial manual exists. You can't just go buy one. So this is basically a guide for creating a perfect, absolutely foolproof set of instructions from scratch, especially when you can't afford any mistakes.
And that brings us to a really crucial question. Why all the strict rules? I mean, why so rigid? Because in high-stakes environments, like military operations, a single poorly written instruction can be a total disaster. The entire goal of this standard is to hunt down and eliminate every single shred of confusion.
I mean, the difference is just night and day, right? A bad manual uses vague language. It skips steps, the layout is confusing, and it assumes you already know things. But a manual built on these military principles, it's the exact opposite. Every instruction is precise, every procedure is covered, the structure makes perfect sense, and it assumes nothing. Absolutely anyone can follow it.
Now, a quote like this might sound super dry, but its meaning is incredibly powerful. It's basically saying, hey, there is a specific way to do this, and you will follow it. Exactly. There is zero room for creative interpretation, no guesswork allowed. When clarity is everything, rules are your best friend.
So what's actually in this blueprint for the perfect manual? Let's pop the hood and really dissect the anatomy of the computer operation manual, just like the standard lays it out. Okay, this page from the standard, this is the core of everything. This isn't just a list of suggestions, it is a mandatory checklist. It details exactly what the final manual must contain, from the cover page all the way to the troubleshooting section. Every single piece of information has a specific designated home. You see how it builds from the ground up with these non-negotiable basics? It demands a precise title page so you know exactly what you're looking at, a detailed table of contents, unique page numbers on every single page, and, this is key, a list of standard definitions so that a term means the same thing on page 1 as it does on page 100. This whole foundation just makes sure anyone can find what they need and understand what they're reading. Okay, so once that solid structure is in place, the manual then walks the user through every possible scenario you could imagine. I'm talking from the moment you flip the switch to the moment something inevitably goes wrong.
The procedures start with the absolute most fundamental actions. First, how to power the thing on and off. Seems simple, but it's crucial. Second, how to get this system initiated. That covers all the setup and commands you need before you can even start working. And just as critically, how to shut everything down safely so you don't damage the system.
So once the system is up and running, the manual gets into the core operations for daily use. It details exactly how to get data in and out of the machine. It tells you what indicators to watch for, like warning lights or on-screen messages, to make sure everything is okay. It even includes procedures for equipment that isn't connected to the main system. They really left nothing to chance.
But this right here is where a great manual truly shows its value. The problem handling procedures. It doesn't just hope for the best, it anticipates failure. It lists potential problems, it explains what every single error message means, and then it gives you a clear step-by-step guide for exactly what to do next, whether that's fixing the issue or performing an emergency shutdown. It's a lifesaver.
And it doesn't even stop there. The manual also has to summarize the system's own built-in diagnostic tools. It explains how to interpret all the error messages and how to run tests to actually isolate the exact cause of a problem. This is so important and empowers the operator to not just report a problem, but to actively help solve it.
So, after breaking down this incredibly detailed, kind of intense military standard, what's the big takeaway here? What is it that great manuals actually do that goes way beyond just a simple list of instructions?
You know, it really all boils down to these 4 key principles. First, they create absolute clarity, no room for guessing. Second, they ensure consistency, so everything looks and sounds the same throughout. Third, they demand total thoroughness, covering every single scenario. And the result of those 3 things? That's the fourth and most important one: they build confidence. They empower any user, no matter their skill level, to operate a complex system correctly and safely.
And that leaves us with one last thought. Think about the last time a piece of technology in your life failed. Your car, your computer, whatever. Did you reach for the manual, or did you just assume it wouldn't help? Maybe the problem isn't the manuals themselves, but the fact that so few are written with this kind of care.